See Standard 10th Max, Chapter 7, Mensuration, Exercise 7.3, Question number 3. From a solid cylinder whose height is 2.4 centimeter and the diameter is 1.4 centimeter. Second point, a cone of the same height and the same diameter is carved out. Find the volume of the remaining solid to the nearest centimeter cube. See, the cylinder height and the diameter is given. See, diameter fully here. Cylinder diameter is given as 1.4 centimeter. The radius is half of this. 1.4 by 2. That is 0.7 centimeter. And the height of the cylinder is 2.4 centimeter. See, this is the cylinder of diameter. Here fully he will get 1.4 centimeter and the height of this cylinder is 2.4 centimeter. From this we remove the conical part which is of the same diameter, base is same and the height also same. Height of the cone also same, 2.4 centimeter. So when I remove this conical part, so question is find the volume of the remaining solid. So first we take the cylinder. You find the volume of this. So volume is equal to pi r squared h cubic units. So you keep pi as it is. And r is 0.7 centimeter. So this decimal you convert it into the fraction. So after one decimal we have the point. Multiply this by 10 and divide by 10. So you will get 7 by 10. So write r as 7 by 10 into 7 by 10 into this decimal also 2.4. After one decimal we have the point. So into 10 divide by the 10. So you will get 24 by 10. Okay. So we cannot cancel any of these numbers. So just you multiply them. 7 sevens are 49. 49 into 24. So if you multiply this you will get 1176 by here 1000. 3 tens are here 1000 pi. Keep pi as it is. Cubic centimeter. This is the volume of the cylinder. From this solid volume we remove the conical part whose diameter and height are the same as the cylinder. So write cone same radius. R is 7 by 10 centimeter and height is 24 by 10 centimeter as we have seen for the cylinder here. Okay. You can write here 24 by 10. So volume V is equal to 1 by 3 pi r squared h cubic units. So 1 by 3 pi r squared. R is 7 by 10 into 7 by 10. H is 24 by 10. So just you cancel here. It goes here 8 times. See, multiply this. 7 sevens are 49. 49 into 8. 392. You write this pi divided by 1000 centimeter cube. So this is the cone, volume of the cone carved out from the cylinder. we have to find volume of the remaining solid. So volume of the remaining solid. Volume of the remaining solid. This is equal to, so volume of the cylinder. So remaining one, how do you get here? We have to remove the volume of the cone from the cylinder. So volume of the cylinder minus volume of the cone. So what is the volume of the cylinder here? 1176 pi by 1000 minus 392 by 1000 pi. So 1000 is LCM. 1176 pi minus 392 pi. So if you subtract, you will get 6, subtract 2, 4 here, 17 minus 9 is 8 and 10 minus 784 pi by 1000. Substitute the value for pi now. 1000 into 22 by 7. Here 7 goes here one time. Then here again one time, carry over 1 2 times. So 112 into 22 by 1000. So you multiply these two numbers, you will get 2464 by 1000. See, 3 zeros you have here. Just move the decimal. See, after this 4 we have decimal. Move this decimal to 3 decimals. So 2.464 centimeter cube. This is the answer. Volume of the remaining solid. See, fourth sum. A solid consisting of a right circular cone of height 12 cm and radius 6 cm standing on a hemisphere of radius 6 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of the water displaced out of the cylinder. If the radius of the cylinder is 6 cm and height is 18 centimeters. See, the figure is given for you in your book. So you can have the idea about that. See, cylinder. Inside the cylinder you have one solid figure, that is the hemisphere, the cone standing on the hemisphere. See, given consists of a right circular cone standing on a hemisphere. First see the unit given for cylinder. The radius of the cylinder is equal to 6 centimeter and the height is 18 centimeter. Height of the cylinder is 18 centimeter. Okay, now come to this. The right circular cone of height 12 centimeter. Radius is same for both the cone and the cylinder. It's also 6 but the height is here they given 12 centimeter. So you need not worry about the hemisphere. So the radius of this hemisphere is 6 centimeter. Okay. So the question is, the cylinder contains full of water. If you immersed the solid figure inside the cylinder, that contains the figure, hemisphere and cone, so the water will be displaced. Find the volume of water displaced out of the cylinder. Okay. See, you need not worry about how much of water contains in the cylinder. See, you worry about the volume of the hemisphere and the cone. First you take the hemisphere. So radius is just 6 centimeter. Radius is 6 centimeter. So what is the volume of the hemisphere? 2 by 3 pi r cube. Cubic units. So 2 by 3 pi 6 into 6 into 6. Here 3 goes here 2 times. So 6 6 are 36. Here 2 2s are 4. So 36 into 4 is 144 pi. See, no denominator number. So just here centimeter cube. Next take the cone. Cone radius is 6 centimeter and height is given for you 12 centimeter. So the volume is 1 by 3 pi r squared h cubic units. So 1 by 3 pi r is 6. 6 into 6 into 12. So here 3 goes here 2 times. Here 2 times. So 6 2s are 12. 12 12s are 144. 144 pi centimeter cube. So this total volume. Total volume of hemisphere plus volume of cone. So what is volume of hemisphere? 144 pi. Volume of hemisphere, cone, again it is 144 pi. That is 288 pi centimeter cube. You substitute for pi, 22 by 7. See here we cannot cancel here. Just I multiply these two numbers and then divide by 7. See, divide these two, multiply these two numbers. 288 into 22, you are getting 6336. Divide by 7. So if you divide this by 7, you will get 905.14 centimeter cube. So this is the volume of the water displaced. So when you keep this solid figure inside the cylinder, water comes out, that is depends on this volume. So the volume of water displaced is equal to volume of water displaced is equal to 905.14 centimeter cube. Thank you.